If Monty Python's Flying Circus taught me anything, it's counting. 1, 2, 5. Welcome to this video on database normalization. My name is Kevin Fiesel, and I'm the proprietor of Catalxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, we moved from first normal form to Boyce-Codd Normal Form. In this video, we're going to tackle fifth normal form. So let's jump back to the professor. Hello, class. As you make your way in, please find a seat not taken by somebody who is fast asleep. Those students were here for my category theory lecture series, so they'll be out for a while. We are now going to talk about fifth normal form. Fifth normal form is simple in definition, but much tougher in concept. The definition is as follows. A relvar R is in fifth normal form if and only if every join dependency in R is implied in the keys of R. At this point, we need to ask an important question. What in the wide world of sports is a join dependency? Well, here's the quick definition of a join dependency. We have some relvar R with a heading H. If we can cleanly break that heading H into multiple subsets like x1, x2, and so on, with no loss, and if we can recompose all of these subsets back together to reform R with no lost rows, no added rows, none of that nonsense, then we have a join dependency. Let's try to explain this with an example. Suppose that we have a relvar called warehouse, whose heading includes warehouse ID, general manager, city, and property tax rate. To motivate the scenario, here's an example relation with some data in it. Furthermore, we have two functional dependencies. First, warehouse ID determines general manager and city. That is, based on the warehouse, we know where it's located and who runs the warehouse. Secondly, city determines the property tax rate, as we assume that all parts of the city pay the same property taxes. The candidate key for this relvar is warehouse ID. So the question is, are we in fifth normal form? The answer is no. We have a join dependency. I can cleanly break this out into two relvars. One which includes warehouse ID, general manager, and city, and the other which includes city and property tax rate. I can do this without losing any information along the way, and if I want to join these relvars back together in a select statement, I can do so without losing or adding data. You might also be thinking to yourself, but professor, this is also true because of Boyce-Codd Normal Form. If that's what you were thinking, go ahead and give yourself a cookie. It turns out that functional dependencies, like what we've dealt with in Boyce-Codd Normal Form, are a subset of join dependencies. In other words, every functional dependency is a join dependency. But there are some join dependencies which are not functional dependencies. So let's talk about another definition of fifth normal form. A relvar R is in fifth normal form if it is in Boyce-Codd Normal Form and the relvar has no composite keys. That's why, in our prior example, we were able to explain the solution in two ways. One using join dependencies and the other using functional dependencies. What this also means is, if your relvar is in Boyce-Codd Normal Form, and your relvar's candidate keys are all single column keys, then the relvar will automatically be in fifth normal form, no questions asked. This automatically covers a pretty large number of scenarios. But not every scenario. Let's look at a different example. Here's a relvar, which includes artist, album, and sales country. This candidate key is a combination of the artist, album, and sales country. This means that it is in Boyce-Codd Normal Form, as we have no functional dependencies, and therefore we have zero cases of a functional dependency whose determinant is not a superkey of the relvar. So, good for us. But I'm going to posit that this relvar feels kind of weird, and we can see it based just on the tuples here in this relation. When we eventually give unnamed future album a name, we are going to need to update 4 tuples. And if we change our mind about selling in Canada and decide to sell the album in Botswana instead, we need to update 2 tuples to keep everything in order. Basically, we need to update multiple tuples when one tuple changes, and this feels a lot like the update anomalies we fixed with Boyce-Codd Normal Form. It turns out this is actually a different type of anomaly, and it comes about because we have a hidden join dependency in this relvar. Artist and album belong together. Album and sales country belong together. But artist and sales country don't really affect one another. They are independent. This means we can split this ternary relationship into 2 binary relvars. Once we do that, the tuples in our 2 relations look a lot better. If we sell unnamed future album in Botswana instead of Canada, that's updating 1 tuple. Granted, changing the album name requires updating 2 tuples in each relvar, though we could also resolve that by using surrogate keys and ultimately creating an album relvar with the album ID and the name. Then we could update the name without needing to update additional relvars. So that's a realistic example in which we see a composite key satisfying Boyce-Codd Normal Form and benefiting from 5th Normal Form. Now let's formalize this a bit better by talking about something called the connection trap. Let's suppose we have the following rules in place. If a store stocks a particular genre, and that store stocks the work of a particular artist, and that artist performs in the aforementioned genre, then the store is guaranteed to sell works in the genre from that artist. This is something known as a symmetric constraint, and whether this constraint applies or not determines whether we risk falling into the connection trap. Here is a relvar containing content for 2 stores, each of which carries specific genres and artists in those genres. If we need all 3 attributes to determine which combinations are valid and which are not, then we are already in 5th Normal Form. In other words, the symmetric constraint does not hold in that scenario. But let's suppose we do have a symmetric constraint in place. If a store sells in a genre, and a store sells an artist, and that artist performs in that genre, then the store definitely sells music from that artist in that genre. If this is true, then we have a set of join dependencies like on the whiteboard here. We can safely break out this relvar into 3 separate relvars, one of which has store and genre, one of which has genre and artist, one of which has store and artist. So here's what the end result looks like using an example relation. We have 3 relvars and a symmetric constraint. And as long as our symmetric constraint holds, everything is fine. Now let's make it interesting. Bad Religion actually put out a prog rock album called Into the Unknown in 1983. After it didn't sell the way they wanted, they went back to punk rock. But let's say that Music Everywhere was able to get a hold of some vinyl copies of Into the Unknown. Now we have a new entry into the genre-artist combination, prog rock and Bad Religion. This means that because Bad Religion has this progressive rock album, and because Music Everywhere sells progressive rock, and because Music Everywhere sells Bad Religion albums, that Music Everywhere must put those vinyls out for sale. This is what it means to have a symmetric constraint. You have no control. You are not in command. Now let's flip the script and say that there's no symmetric constraint. The only results we should see are from the original relvar, and each store gets to decide which combinations of genre and artist they sell without any logical mandate. Let's break that data back out into the 3 relations, and then we're going to add back in our copies of Into the Unknown. What happens when we join this data together? Well, we know that Music Everywhere sells prog rock albums. We know that Music Everywhere sells Bad Religion albums, and we know that Bad Religion has a prog rock album. So that means if we join these three relations together, we will end up with 4 rows, not 3. This is called a phantom row or insertion anomaly. We didn't have that row before, but when we join our 3 tables together, it suddenly appears. In this case, the only way to fix the problem is to understand that because we do not have a symmetric constraint on our ternary key, we only have 1 join dependency, not 3. By the way, suppose we want to know that Bad Religion had a prog rock album, but also want to know that Music Everywhere does not sell it. How could we do this? The answer is that we have 2 relvars, one which shows store, genre, and artist, and the other which shows genre and artist. This may feel like duplication, but we've already proven that we need all 3 attributes for our relvar, as the unique combination of genres and artists may differ in this ternary relvar compared to the binary relvar. So that's one big reason why we should care about 5th normal form, insert anomalies. The second big reason is deletion anomalies, which is a similar idea where we can end up losing information by breaking a relvar out when there is no join dependency. Both of these are really bad outcomes. The third reason why we should care is if we don't have any composite keys in a relvar. Boyce-Codd Normal Form is 5th normal form, so we get 5 and F for free. Now there's one more reason to care about 5th normal form. Symmetric constraints aren't extremely common, but there is a rather common variant about which I'd like you to think. Of course, the bell's just about to ring, so we'll have to save it for next time. Class dismissed, assuming anybody is still awake. That was 5th normal form. 5th normal form is tougher to conceptualize than Boyce-Codd normal form because join dependencies are a bit murky of a concept. Where functional dependencies fit really well in mathematical terms, join dependencies, at least to me, they tend to feel more mushy. Like you have to try out the combinations to see what might work. Even so, spending the time to dig into this form is definitely worth it, as we solve the kinds of problems we might otherwise run into if we stop at Boyce-Codd normal form or, horror of horrors, 3rd normal form. We'll have links and show notes in the description below. And until we see each other in the next video, take care.